could just cover that.
Sure. See, yeah, last week we covered LangGraph implementation of agents. So LangGraph is again a framework for you to build these complex agents. Okay, there are multiple other frameworks. It is last week was very specific to how to use LangGraph to build these agents. Today we are simply going to talk about what are agents in general and how do the agents actually work. Just like an overview of that. Ideally, would have been that we did this ONO one first, then we did LangGraph. You know, Google has done something new. There is one more we are actually coming up with, Agno, right?
Yeah,
so
Agno.
That we're coming up with. So, like, we are having these sessions, getting in depth into how do you build and work with these agents. Today, just going to be an overview on how agents are, etc. Yeah, I think we are ready. Super. So I'm gonna share my screen and I'm gonna disconnect my video because my laptop hangs if I have my video and screen sharing open at the same time. All right, just give me a second. Come on. All right. So yeah. So step number one. So we'll guys, I can't see you. So if you have any questions, I would request you to just call it out. Okay. All right. So step number one is, in general, you have what is called an assistant and what you call an agent. Okay. So example, what is an assistant? For example, ChatGPT is your assistant, right? Now, ChatGPT is also agent. I'll talk about the differences. So, for example, if you simply have a question saying that, hey, how far is Delhi from Bangalore? Oh God. Yeah. So it does a bunch of these things. So basically, an assistant is this. Assistant has some memory. That means it has some knowledge. Not memory. It has some knowledge. You can also augment the assistant with your own external knowledge. You ask a question and the assistant will actually help you answer that question. Okay, that's a very simplified way of thinking about assistants. Now, what you call as an agent is an assistant plus an action. Okay, so agent is something that can take action along with simply providing the information. For example, if you take, like, the ChatGPT interface, you have these options called search. Okay, so this is an assistant with a tool called search. So it can actually do, you can use this particular tool. We'll talk about how it actually works, but it can use this particular tool and perform certain actions like searching the web. Okay, search here simply is a tool. Similarly, you have, for example, DALL-E. Using DALL-E or this image generation, you simply create an image. That is just an assistant because it is using its in-house memory, etc. But if you want an agent to go and book, let's say, a ticket, what you have is OpenAI operator, etc. Okay, or you have something called even tasks, if you remember. So this basically has stores its tasks for you. It has a task database. Whatever task you mention, it stores it. It can alert you, etc. So those are tools. Okay. So these are additional tools you can augment with a particular assistant to make it like agentic. Okay. So here is again information plus action. So it can actually take action along with simply providing information. So that's the simplified definition of what an AI agent is compared to an LLM or an assistant or whatever. Now, in terms of internally, like going a level deeper, so it's basically LLM plus memory. That means you have your own memory plus knowledge base, etc. So that is basically your assistant. An agent is, along with an assistant, you also include tools and also other LLMs. Okay, so tools could be like search is something we just saw right now. So task is a different kind of a tool, right? If you want to do, let's say, book a calendar, so that's a different kind of a tool. So these are some examples you can think of. Actually, I have. So an example is like, for example, DALL-E image generation or normal GPT or Claude or whatever you actually use. So that is just an assistant. but you add task of capabilities, your research capabilities. Research, because it uses a lot of internal web browsing, figuring out that link, parsing that link, do browse again, summarizations. It does a lot of these things together, and there are a bunch of agents involved in researcher. It's not just one agent; it has like multiple agents. So that's why it just comes under an agent. Okay, OpenAI operator, where it accesses your browser, it goes searches, it clicks a button, it does all of those things. So that's also an agent compared to a simple assistant. Okay. Example use cases is very straightforward. So for example, summarizing text, you want to write emails, you want to provide a PDF and give an analysis. So all of those things are simple assistants. Okay. In case of agents, you can think of like booking tickets, sending emails, send emails in the sense like, can you ask the agent to simply send an email automatically? So those are use cases which are like slightly more agentic. Read from your database is basically agentic. Filling calendar, you have these agents which write code, right? So that's also agentic. If you remember Claude has this thing called artifacts where it can write code, it can execute, it can show all of those. Those are simple existing Claude LLM. Along with that, you also have corresponding tools. Okay, so that's the main difference between assistants and agents. Any questions on this? Is this part clear? Anyone? Okay, I'm assuming it's okay. So, generally thinking about like where do you actually use agents? Three areas, main areas that at least I have identified. One is open-ended problems. So open-ended problems, for example, is let's take something like calendar scheduling. So why is calendar scheduling open-ended? It's because take an example. So I'm going to simply say like, hey, like, can you book there is an agent? I'm just pinging the agent or sending an email to the agent saying that can you book a meeting with Praveen? Now it's a slightly open-ended problem because it needs to understand, it needs to find out my calendar availability. It needs to find out Praveen's calendar availability. There will be preferences for when we want the meetings to happen. There is, we don't know the agent doesn't know the the time slot, like how long the meeting has to go for, what is the preferred time, what is a what do you call the conference link to use. So all of those things are slightly open-ended. The agent needs to figure out using using the initial request, asking questions to the person, then using the previous experiences as a memory, and finally have access to the tool which will schedule the calendar invite. Okay, so these are like slightly open-ended. Now, for example, let's take agreement signatures as another example. Now, let's say you have 5 people to sign an agreement. So the agreement could have X number of people to sign. Their email address could be different. And if they have questions around what that email, what that agreement actually does as certain terms, the agent should be able to understand and like respond to that. And it also need to be able to send the agreement for signature. It needs to be able to send reminders. It needs to do a lot of those things, which are slightly open-ended, which is not very, very straightforward and fixed. Okay, so which is second. So the second one, which is you'll actually end up seeing a combination of all of those. Second one is like a multi-step process. Okay, like for example,
what the screen is not visible.
What? Oh shit! Sorry, guys. Yeah, just call it out. Is it visible now? Yeah. Sorry about this. Yeah. So second one is if you think of it as multi-step. Yeah. So multi-step process. So this is the most common thing that you will actually see in most of the agents, right? So now let's take, for example, this deep research stuff, OpenAI. When you, that's exactly what happened here also. So basically, when I send this query, what it did is it went to all these sources, different sources. It tried to extract their information, finally summarize the information, and then provide me the input. Okay, so which is very, very simple. But in the case of deep research, this is a normal search. In the case of deep research, what happens is it, I don't have something that I can show right now. So it basically what it does is it first of all understands the query, asks clarifying questions if you guys have actually used it. The second step is it creates a pattern of what are the things that I actually check for, right? Like list of things that we need to analyze. And then it does Google search or like any kind of search for each of those queries. And it aggregates information. Then if there are follow-up questions, it tries to go back and do research on that also and come back. So there are multiple steps involved in this particular process. Similarly, even if you take something like calendar scheduling, it is a multi-step process. The first step is, hey, do I have availability of all of this? If it is not there, go check get the availability for all of the people who are actually involved. Third is, do I have the time slots and other things which are actually available? If it is available, then let's say book a meeting. So these are like multiple steps that is involved in solving this particular problem. And a typical normal LLM won't be able to do this. Okay, so that's why we have these multiple steps. Self-improving systems, like for example, if you look at like customer support agent, if the customer says this answer is helpful, you might want to continue that kind of answer. But if the customer says the answer is not helpful, you need to probably change, right? So similarly for sales SDRs, like if somebody is doing an outbound call, that system also needs to keep improving based on new information that is actually provided, how the customers are responding over the call. Are they picking up the call, not picking up the call? Are they interested? Are they continuing the conversation? So a lot of these things are actually involved over there, right? So these are some of the areas where you end up using agents. Any questions on this so far?
Bala, even in a prompt, right, you can give step-by-step instructions, do this, do that, like 1, 2, 3, you can give step-by-step. When do you decide that a prompt won't work and you have to go for an agent?
Correct. See, the general principle is that, like, if you've given prompts to each of these agents, the agents can do fairly well, but the predictability kind of goes away. In some cases it works, in some cases it actually doesn't work. Like for example, let me take an actual example, right? Now let's say I want to do a meeting scheduler. Okay. Now I'm going to tell the LLM, see, you get a request. What you do is you go try to get the availability for both of these people. And if the availability is there, try to understand their preferences. And if the preference is there, go ahead and schedule a meeting. I can give all of those instructions. But it will probably work, even in the best case scenario, it will probably work 70% of the time today. Okay, because you have to take care of all the edge cases. What if that person has out of office for the next 5 days? What if the time zone is actually very different? What happens if the that person's calendar is not available with LLM? Right. So a lot of these edge cases start coming up. Your prompt is going to become like multiple pages, and obviously the LLM won't do the job really well. Right. So the good way to think about this is something we've talked about a lot in the past sessions. So a good way to really structure anything that you are building is that there should be a separation of concern. Each LLM within an agent, or you can say it in multiple ways, like each agent needs to have one specific job, just like a human being. As long as you make it very, very specific, this is the job that you are supposed to do, it does it really well. That means your predictability is actually going to go up, and if the predictability goes up, your output will be much more reliable, right? So that's the general principle. So any job that you actually do, it is better for you to kind of split that into specific functions as a general principle, as small as possible. Like don't go too small that it is going to impact what you're actually building, but as small as possible is what we actually recommend based on our experience. Tara.
Yeah, hey Bala, I just had a kind of a similar question, I guess, Sharath, and I don't know if this was touched upon earlier, but is there like along the same lines, right? Like in terms of deciding when to just use a couple of basic prompts to get the job done versus having to use like a custom agent, does it have anything to do with the amount of memory and how different is that, you know, between like a regular, you know, let's say ChatGPT conversation, which is just supposed to be like a very general kind of use case versus going for a custom agent, which has been trained, let's say, on a certain set of frameworks or a knowledge base, right? So is memory a big part of this? You know, you have to keep that in mind, right? To really decide which of those options will give us a more accurate output. Like I've been dealing with this a little bit. I've been wondering, does it even play like a really big part or not?
Not really. Memory usually doesn't. because you have enough memory, right? So ChatGPT can actually do very well. And if your memory becomes too big, there are concepts around RAG, like how do you embed and store the information. So you can use search so that within large amount of memory, it can get relevant conversation, summarize and answer. So all those capabilities are already there, right? So memory is not going to be your problem. There are techniques which are better, which kind of keep improving.
Sorry, just a quick thing. Sorry, there before you continue, right? What I meant, I think, by the memory question was, so let's say I sometimes have use cases where I have to keep going back again and again to the same use case. Let's say it might happen a day later, a week later, or sometimes even a month later. If I have to kind of go back to a conversation where it was just a series of prompts, let's say, and it wasn't really a custom agent for the sake of example, I get this feeling that like in the beginning, obviously, because things are fresh and it sort of remembers kind of what I've asked. That's the kind of memory I'm talking about in that session, perhaps. That is a big part is what I have seen or that's what my hunch is. I'm not sure if it's a hypothesis at this stage, but I've seen that, let's say for whatever reason, because my use case was such that I didn't have to do it for quite some time, but then I have to come 1 or 2 months later. I find that it struggles, right? So obviously, I think it has forgotten some of those things because there are other conversations which I've probably missed up a little bit with. Yeah. So does that play a part in this decision of what to use?
So not really. So that is a problem, whatever you actually use, because even agents is using LLM. There are two scenarios where you will actually use agents. Number one is that if you're using tools along with your LLM. Okay, so tools, for example, if you use ChatGPT, I give the same example. Like, for example, you want to have reminders which are actually set up over a period of time. So then you need access to a tool where it can store your reminders, what time it has to trigger, so all of those things actually come in place. Let's say you want to do additional search, so they have these search capabilities. That's actually a tool. Or you want to do a data analysis. When you put a CSV in ChatGPT, what it does is it doesn't give you the output directly. If you enhance the operation that is happening, it writes a bit of code for math operations. Because the LLMs are not good at math. What they use is they use something called a math tool to send the input to the tool. Math operations happen over there and gets a result and tells you. So when you need capabilities beyond simply like talking about it, so when you use these additional tools, that is where you use. And this is the same as additional tool can also be another LLM. Okay, we'll talk about those things in a bit.
Sure. Yeah.
The second use case that you use it for, and this is a must, is if it is like a workflow. It is not a one-off thing. If you're simply doing research, you can go do your normal LLM. You can even give access to tools and all of those things. But when you have a workflow, when it happens over and over and over again, the process is very similar, and that's where you actually use an agent, because that is where your accuracy comes into picture. If the LLM makes a mistake for a normal conversation, you can always go correct it, ask a further questions, etc. You can do all of those stuff. But when you do it repeatedly, then you need to make sure that the accuracy is actually very, very high. If you remember, like CP, whatever he presented in agent.ai, it is basically a standard workflow.
Right.
Like, for example, you want to get company information, provide the URL, and I give the entire company information as output. That is a repeatable process. I need to keep going back and again to do the same process again. That means accuracy needs to be higher. So in that case, if we see, there will be tools which are used. So one LLM does this, second LLM does the summarization, all of those things, right? Yeah.
Got it.
Jim has also mentioned like there is a memory concept that ChatGPT has actually launched. Yeah, memory feature, which is yesterday whatever they have launched is very interesting. It remembers everything about you forever. It is also a bit scary. If you guys haven't tried it out, just go and ask like, hey, what do you think about me based on my conversation?
Yeah, it's everything about you, your past conversations, and then starts referencing that, like, what's your favorite color? What do you can ask questions like, what do you think about me based on my past conversation? It'll profile you and give you. And the good thing about that feature is also they allow you to, if you're a pro user, I think you can actually go a plus user. You can actually go and even edit the memory. You can add certain repeating workflows saying that, hey, this is something that I'm going to use often. So remember this for me, and if you're going to reuse that once in a while, it'll remember and then make sure that it uses that while answering. So memory feature is quite interesting. I think memory, like there's two memory, right? Like the short term and the long term one. The short term one within your particular context, that's pretty interesting. But then the long-term one is what ChatGPT has launched, right? Like across sessions, it'll remember about you. It'll remember about what workflows you've run. That's super interesting.
Yeah.
It's interesting, man. Thanks, DMK, for sharing. I'll definitely take a look. There was also a fun thing where people were asking it on very similar lines. People have been trying this thing saying, generate an image about me based on what you know, and people have got surprisingly accurate, but also very, very inaccurate and funny. Good right out.
Yeah.
Thanks, guys.
Okay. Cool. Let's move on. Yeah, just keep the questions coming because this is going to be a slightly lighter session. Okay. So I've taken an example. I've taken the scheduling agent as an example. This is scheduled calendars as an example. Create a rough flow chart of how an agent, scheduling agent, if somebody is building, is going to look. Don't worry about the implementation. There is no implementation. So this should give you an understanding of how these agents actually look and they'll work. Okay. Now I'm going to run through the workflow. Then I'll talk about these individual. Okay. Now let's say somebody sends an invite. Somebody asks us. So this is an entire thing is an agent. This is the user who is sending a message. Okay. So the user is simply asking the agent saying, "Can you schedule a meeting with me?" Okay. Now once it actually comes in, so you will as a user you will I think it's like ChatGPT. It's like just on an interface like this. It will not be any different. It's just one input. It's just like probably a chat window or a WhatsApp or an email or whatever, right? It comes into it. The way this agent would be structured is first, for example, there is a validation agent, and if the message is valid, it goes to the main scheduler. Okay, I'm gonna switch off my video, guys. Give me 1 second. Okay, just give me 1 second. So you have the main scheduler. The scheduler will try to fetch the calendar availability from calendar tools. Then it also gets some more details from the long-term memory. Then it uses an email agent to draft and send emails, and finally it sends a response. So I'll tell you how it will actually work, typically step by step. Now let's say I have a schedule. I ask a schedule. First thing is this agent is meant for scheduling. The problem is, let's say you put it behind an email. A lot of people will send you spam emails. People who are not authorized to book meetings with me might send a request to this agent, right? Which is the agent should actually discard. So all of these are like custom logic. So this you provide an LLM, and you give this LLM access to its own memory in terms of who are the past people that you have been connected to, my preferences in terms of who can book meetings with me, cannot, right? What are the kind of meetings I can actually take? So what to do if there is a new request that is coming in? So all of these preferences I can store it somewhere and give access to this agent, this LLM. What it'll do is once it gets a request from the user, sorry, any email, it will simply say whether this person is authorized to book a meeting with this person, or is it actually even a booking request. So this validations agent is responsibility is only that. And if you really think about it, there are enough edge cases in this process that this agent itself will be really, really big. The prompt will be so big, your conditions, criteria, it will have its own tools, etc. So this itself will be fairly complex. Okay. Now this is one agent within this larger agent. This is one LLM. The second one is there is a master scheduling agent. So this is the main thinking agent. If it were me, within this agent, I'll have another flowchart like this, which is a smaller flowchart, where it will have its own thing in terms of, do I have all the information which is actually available? Who do I ask the information from? What are the preferences? How do I actually think about the availability? So I'll split these into different separation of concerns within it so that it performs better. But for our discussion sake, let's just assume that it is like a single LLM. So what it will do is it gets a request, it's a valid request. It will check whether I have access to this person called Mark. Okay. So that comes from the long-term memory. So long-term memory, as GMK mentioned, is imagine that it is like a database or even a file, like just a file, which can have things like actually a long-term memory will actually look like this. So for example, something like people, and people you will have multiple things. So you'll have name, I'll say Mark Anthony, and you'll have role, I'll have, let's say, product head, and then I'll have something like email. I'll have something like last spoken, last met with. I can have it's on preferred time, etc. So this is, you'll have multiple people, people 1, people 2, people 3, all of those things. So it's very simple. Imagine, so there are more complex way of doing this, but imagine it is just like a text file where, or an Excel sheet where you maintain all the information in the past. So the scheduler will access that. It figures out who Mark is. If Mark is unknown, it has to ask this guy who Mark is. So it will, how can it ask? It can send an email to the person. So it will call an email agent saying that, hey, send a mail to Bala as a response to the previous email asking who Mark is. So it will think and it will use this agent to send an email. So this agent will be capable of drafting a message and it will have access to the email tool to send an email. Okay, I'll pause here. Let me know if this so far is, if this is clear. Okay, I guess it's just, let me know if things are not clear. I'm happy to explain this again. So again, like, so this agent now sends an email. Now, once it sends an email, it also have a, yeah, Vishwadeep.
Hi, Bala. I just wanted to ask that you just now mentioned that accuracy in one of the agent is somewhere around 70%, right? So in a workflow, if we have, let's say, sequentially like 2 agents, I'll take hypothetical example. So will the accuracy be 49%?
See, the accuracy is 70%. I said as an example, if you put all these logic within a single agent, right?
Yes, no, I'm also like, let's say it can be 80% also. I'm just trying to arrive at an accuracy of the workflow based on the accuracy of one particular agent. Let's say it is X%. So will the accuracy of the workflow be 1 minus X square? Like how do we evaluate this, the performance of the overall workflow as a system?
Exactly, you're actually right. It will be if you have X number of agents, right? Your accuracy is going to get multiplied. So let's say this is X and this is Y. It's basically 1 minus X into 1 minus Y. So that's how the accuracy is going to. That's why it's very important for you to make sure that this is as close to 100%. Each agent is as close to 100% as possible. And how do you get to as close as 100% as possible? Making their job very specific and very clear. There are no ambiguities in the job.
Can you give an example of this? Because see, for production grade, anything we make, we will have to point out some number and keep it as close to 100%, if not exactly 100%. So how can we go about this?
So basically, for example, let's take this validation agent. Okay, so I add a validation agent which will validate the incoming request. The way you evaluate is you create a test set, you send it to the validation agent, see if it actually works, and keep changing the prompt. Okay, that is one. Second one is when you keep changing the prompt also, some LLMs do certain jobs really well. These kind of decision makings I have previously found Llama is a little better, and Ken is also a little okay. ChatGPT definitely is like an overall good, but it's also slightly more expensive. So between cost and the accuracy, you can choose one of the LLMs. That is part number 2. And number 3 is see if the validation agent doesn't perform so well, split this into multiple agents again. For example, one agent only checks whether the incoming request is a relevant request. That's all its job is.
Okay.
Second agent is responsible to see if this person has access to do all of this. The question is relevant, but the person has access could be done by somebody else. Okay. And third agent is what is it?
So again, the question comes down to if we increase the nodes, the accuracy reduces. So that's what my question.
Not really. If you increase them, see, it's about accuracy is how well the LLM is able to do this job. Job. If I give it 5 tasks and together, and it asks you to do 5 tasks on a given input, it might perform, let's say, at 70%. Okay, so your outcome is 70%. So now let's say, but if I give one task to an LLM, I split the existing LLM and the existing jobs into 5 LLMs. Okay, and so the new LLMs, each LLM has only one job. Let's say it is at like 99.5.
Optimize between the accuracy of each individual node versus the number of nodes, I believe.
See, you care only about the overall accuracy. Right?
Yes, right.
So if you split the jobs into smaller LLMs or more, make it more specific, the accuracy of each LLM goes up. Okay, so let me give an example, right? Sorry, I just disconnected myself. Sorry about this. I'm just going to quickly do this. Okay, so you have, let's say, one validation LLM. Okay, so which gives you an accuracy of 70%. Okay, now this validation, let's say, has 3 parts. So I'm going to split this into LLM1. Let's say 1, LLM2, and LLM3. Okay, so this performs access checks. This performs, let's say, query validation, and this performs, let's say, redundancy checks. If this request has already been, is it a duplicate request? Things like that. And because I split this into multiple ones, each of the accuracy could be much better. Because it does this job, this does this only one job. You have a smaller prompt and it does really well. So in this case, so it's a 90% accurate. So you are basically going to have error rate as 1 minus I forgot the.
Got it.
So basically you do a multiple of 1 minus this exactly. So 1% into 1% into 1%. Or the other, actually it's 99%, right? So equal to 99% into 9% to 99%. So you have 97% accuracy compared to 70% accuracy. So this is essentially math.
Got it. Thanks.
Okay. Yeah. So Anshul has also shared the. Yeah. Yesterday, I think I heard this evals. That's a very good talk. Actually, we should check it out.
Yeah, I think we should have a talk on eval at some point. I think.
Yeah, we'll get an expert because I don't have a lot of experience on this. We'll try to get somebody who has done a lot of this.
Makes sense.
Super. Cool. Just moving on. So now, as we said, like the scheduler will check his memory to see if it knows Mark. If it doesn't know, it uses email to send. If it knows who Mark is, it tries to get his preferences, and it also needs to get the calendar availability of both Bala and Mark. And how do you get calendar availability? It has access to another agent, which will share the calendar availability, and that agent will have access to the tool called Calendar APIs. It's basically your Google Calendar or Apple Calendar or any calendar will be available. So you provide those APIs as a tool to this calendar agent. So if the agent gets a request saying that, hey, get me the availability of this person, it will just fetch the corresponding person's calendar using their credentials or whatever, and it sends it back to the master scheduler. So that's its job. Okay, so the master scheduler will have calendar availability. It will have the preferences. It will get additional information if it wants via email, and then it will send a response saying that I've scheduled the meeting. So this, if you are building somebody like a scheduling agent, a simplified version looks like this, and it is impossible for you to put all of this information in a single LLM. Here, an agent, because it has its own responsibilities, has access to tools, and it has access to other agents, etc. As a network, it can perform this job much better. Cool. Questions? Let me know if this is clear.
I have a question here. Can this scheduler API reschedule any request?
Depends on access you actually provide. So, for example, in the calendar tool, if you give an input saying that, give me this is the tool that you use to reschedule meetings, then it will have that capability. Very simple that way. So, okay. So, for example, this is a very interesting concept. So, one of the things that is going up quite a lot is the more tools you provide, the LLM actually. So, the certain LLMs have more capabilities. Okay. So, more tools you provide, it also gets confused on when to use what. But it's as simple as just saying that, hey, like you have access to calendar, you have access to my email, you have access to WhatsApp, you have access to, let's say, a weather API. It could be all of those things. So the more you actually provide, it simply accesses, it knows how to access this. That's all. Okay.
Got it.
Marshall, hi. Yes.
Hi, Vala. So my question was around again. I might be digressing from the core concept of agents, but what about security? Because if I were to give, say, access to my email for whatever information that the agent would be reading, how would that lead to, say, any personal information leakage or whatever that the LLM might read into?
That's a very, very good question, actually. So this is something that you should be very careful of. To be frank, it is not a fully solved problem. Like whoever is implementing it has to take a lot of time to make sure that it is done properly. Okay, that is number one. But with that caveat, let's say I want to make sure that the security is actually available over here. In the calendar availability, I'll have a again a smaller validation node to make sure that only authorized people can request for calendar availability here. And this main scheduler agent will not have access to the calendar at all because it cannot directly access. It always has to go through the calendar, and the calendar will also have a validation to make sure that it only the authorized people can actually send this request, and all those requests are actually logged. So this is how you kind of like set up. I'm sure there are more intricacies into how you actually build it, but you basically say that if you want access to, let's say, this DB or this calendar or like my email or whatever, you restrict to one person, and the one person has proper access control on who can access what and what information can I actually share. For example, one of the things that we did is we had a chat agent to consumers, and one of the things where we spent a lot of time is to make sure that people cannot get information like what happened with Krutham, right? Hey, oh, like which do you run on? It said OpenAI, built on OpenAI. So those kind of checks. So that's where all these checks and balances and validations and other things are actually put in place. And there, just a prompt is not enough. You have to do more. Simple having prompt is not foolproof, because even if that one person it fails, it becomes too much of a problem.
Okay. Maybe one follow-up question. I think there are some more questions here. So if I were to do this, say for an app where I want to invoke an agent from an app, apart from the other workflows that are happening, and that would require the agent to read through, say, somebody's emails in order to for them to retrieve some information. And if it fetches some financial information as well and it trains on it, I don't know like what the agent or the underlying LLM model might do on their part. So is there a way to say split that in a more secure way if you have any inputs?
The way I would just follow the proper engineering practices here. Forget about LLM. There is nothing specific to agents, etc. Your engineering practices, the GMK just mentioned. So role-based access controls, right? Though you have multi-tenant systems, you have IP restrictions, you have access keys like bearer tokens. So just the proper engineering practices so that only authorized requests actually hit the LLM. Right?
Okay.
That is the way to proceed over here.
If it's okay, I'll share one quick example here. So one of the agents that we are building is trying to it's like an analyst agent, right? So given a large data set, it tries to run SQL queries and get output, right? So the same problem right now, SQL is when LLM start writing SQL, they can start doing updates. They can start pulling data that is not relevant to their questions, or it could also be sensitive data that they start pulling. All of these problems happen, and obviously we use the output to retrain the model, improve the model, and all, right? So the way that we've tried to address this is, instead of using SQL, which can just do everything, we obviously role-based access control. So only read access, no write access. Then we built over the table so that only certain tables can be accessed. Certain tables will get failures if it tries to access also. And then even over that, we built like instead of writing direct SQL queries, what we did was we built like a domain-specific language, which could only request for certain things. It was taught only to request for certain information and not go beyond that information. So all of these kind of ensured that the underlying data is not polluted. it doesn't access unnecessary data, and then that does not use to train, right? So there are techniques depending on your use cases that you can leverage to make sure unauthorized data accesses. And again, all of these are mostly engineering techniques, not LLM or techniques, like what Bala said.
Thank you.
So this, sorry, just digressing a little bit. So this is it's a nice tutorial by Landgraf. Don't worry about that. So this is an example of a customer support agent workflow. Okay. So user simply sends a request. It comes to the main assistant, which figures out if it is related to flights or hotels or car rentals or excursions. Okay. So it delegates to those agents, and each of these agents will have access to its own like tools. So each of the agent has its own assistant, main assistant. Then it categorizes certain tools as safe tools. That means I can simply access those information without any approval. There are some things called the sensitive tools, which are, let's say I want to update the flight, etc. It can't simply go and update, the LLM can't simply go and update, it always needs a human approval. So it goes for an approval. And when the human approves that the request is fine, then it actually does an update. So this is an example of how do it at an LLM level. But whatever GMK said definitely holds. Like the first step is think from if you're building a system, think from an engineer's point of view and put all those restrictions, which is like proper 0 or 1. Because LLMs are always probabilistic, they're not deterministic. So they end up making mistakes for sure at one way or the other. Okay, sorry, Himanshu, yes.
Yes, hi Bala. My question is on this master's agent that calls like sub-agents. So how does it decide which agent to call? Is it something that we have to define the prompt? Or
it's basically prompt. You simply tell it the prompt saying that this is how you actually design. If you want to use email, you use this. If you want to do this, you do this, etc.
But let's say there are 10 APIs, right, that it can call, and they have very generic name, or let's say they have names that is not human readable, right? I've given some random names to those APIs. And when I say that, hey, I want to check my flight, right? How does it know, like, do I need to give the metadata of the to the APIs based on which it figures it out?
I'll tell you, for example, let's say go to hotels. So this is an example of a tool. Forget about all the code. Yeah. So I simply say this is a tool. The tool's name is search hotels. And I'll have definition, like ignore all of this. This is how the tool works. So, etc. So when you give it in the prompt, you simply say that, hey, the search hotels is a tool you use for searching for hotels. Or you give an instruction like this. So saying that this is for searching the hotels based on location, price, tier, etc.
Got it.
And what is the argument of what do you call, what is the input you need to give to the tool, and what is the return a response format you can expect from this tool. So the LLM, you simply say, hey, there is a tool available. The LLM will read this and it will know how to use the tool. What is this tool meant for? You can also tell the LLM in the prompt saying that if you want to search hotel, use this tool. So that's the prompt.
Understood. Got it.
Anshul?
Yeah, but I have a slightly more meta question on this, which is to say that once this becomes more mainstream, right? Somebody in the company would have to define these sub-agents, like would have to look at a use case and define a system of sorts where it will have interaction between multiple agents. Now, who would be the, like, who do you think in the long run would be the right persons who will be defining this? Would it be more like a PM archetype or an SD4 archetype? The reason that I ask that is traditionally this has been done by SD4s, right? Which is their brain is trained to think systems, and PMs are generally not that versatile with this kind of a skill. So this is just more of a general question that I wanted to ask. Where do you think it is headed?
I don't know. Probably others can answer this actually. Because I think those two things are converging. So GMK, sorry, go on.
Yeah, so it's doing so. So I happen to work with a few companies who are trying to do this, right? It's a combination, actually. So there are typically IT admin / platform teams within each company. What they try to do is they try to create a tool library or an agent library. I mean, a larger version of this is what Prashant had shown, right? That agent.ai. That's basically a library of all agents, right? So something similar, each of these companies are trying to do. They're trying to, all the APIs they have. Let's take something, right? Let's say Microsoft, right? Let's say Microsoft has an API to create a Excel file. So what they do is they build wrapper SDKs on it and put it on tools, put it on their tool library. Now the tool library is defined by the agents, the PMs, and the SDs. That's what I'm seeing. It's not like the SDs, the engineers define the tool libraries or not. Again, PMs who are defining this are fairly getting technical in terms
Yeah, I
of.
think you're referring to is more of a platform PM architect, which is like a combination of having technical skills as well as a business acumen as well as product sense. What I'm more looking towards is like once you have built the platform, then somebody has to use those capabilities. That is where a feature PM kind of an architect comes in, right? Which looks at all of these capabilities and how do you join it. And then there is a SD4 who is looking at, okay, how do I structure this? Now I know it's a slightly open-ended. I'm just trying
No,
to.
man, it's being done by both again. Like what Bala is saying is same, right? Like the PM persona and the SD personas are all getting converged into a builder persona.
Okay, that is what you
Yes.
think there is headed. Okay.
It's one of the reasons why all of us are here, right? So it's the builder persona that is getting more prominence, and it's not like, hey, my boundary is this, SDs do this.
I think that is where whenever there is a disruption, obviously there is scrambling to assemble the pieces. That is where we are right now. But I think once this cliff has passed, roles would emerge, right? Like even if you look at the initial of product management and software in general, PM as a function did not exist, but people realize that hey, we need this. Now, similarly, this is merging, but I think it will divert at some point. Probably we'll know at that point as
Can't
to
predict
where.
that. I can't predict, but merging, I agree with Bala. Like, yes,
Yeah.
as a
There is
total
a
merging.
there is an interesting conversation I had with a really large multi-billion-dollar company recently. The CEO mentioned there are only two roles he sees in the future. One is a problem solver, and second is an auditor. He says everybody needs to know code, everybody needs to do auditing, and everybody needs to write evals, etc. So that's how the org is actually going to be built. It
I
was
think,
very
yeah,
revolutionary.
I think the best article that I've read on this topic is from Marty Kagan. So Marty Kagan says that hey, right now the product team was 1 PM, 3 designers and 7 engineers. It's gonna converge to 1 PM, 1 designer and 1 engineer. I think that is his prediction, and I think that is like where my brain is at. But yeah, obviously we'll get to know once we reach there.
All right. Sure, it's just jumping like Sriram. Sorry, I have a question.
Yeah, hi. So practically, if you have to build a agent with tools and all that, so what is a good framework basis your experience, which is LLM agnostic, which gives you more control and does not abstract on the SDK a lot?
Got it. See, if you want to get to based on our experience, right? So if you want to get in depth and you really want to have a lot of control over the flow, the control, everything, so LangGraph is the best one we have actually seen. We've done a session last week. The recording is already available on YouTube. You can check it out. All the other frameworks, you have seen that if they're highly abstracted, it is very easy to get started. We are going to do a few sessions on those things also. They're very, very simple to work with, but they'll not give you a lot of control. You can't get to productions, etc. Right? But they're very easy for if you want to do some hobby projects or then you want to touch on agents. So it's LangGraph is what I would recommend. But it's also very complex. It's a nightmare to work with LangGraph.
Okay, so you're saying it gives you a lot of control, but it's also comes with complexity. But
Yeah, it comes with complexity. It needs a proper engineer's mindset.
otherwise, what is the other framework would you recommend if the use case is not that complex and you're like,
see, Google launched one yesterday. I'm planning to try it out. TPK has played around with something called Acmo. There is a OG one called Crew AI, which is very famous. There is one by Microsoft. I forgot the name. Teach, anything else you can comes to mind?
The Agno and Google seems to be similar. So Agno is more simple to start with. Maybe that's the first place. Crewway, I think, is more for enterprises, even though it's a little more simpler than LangGraph. But Agno seems to be a lot more simpler. Folks who are getting started.
Got it, got it. What's the YouTube channel called for this? It's just Applied AI, is it?
Applied AI Club. I think there are a lot of Applied AI, so we changed it to Applied AI Club.
Got it.
Yeah, we'll also send the link.
Sure.
AutoGen.
Thank you.
Oh, yeah. Microsoft boys here. Cool. Yeah, just last, right? So one is about agent evaluation. So this is becoming more and more important if you're really thinking about building something internally, right? These are like test cases, and especially with LLM where mistakes can be a lot. These are becoming more important than building the agents themselves. With pipelining and etc., building agents becoming easier. This is where things are getting harder. So few general principles. How do you break down the evaluations in general? These are just tests, like unit tests or any other tests. Right? Intent evaluation, whether the LLM has understood the intent properly. What is the question about? Tool call evaluation, is it evaluating the right tool, using the right tool for the right things? Outcome evaluation is whether response is actually proper. So some basic structure around how do you think about evals. Cool. So before we lose time, I thought I'll practically show you one example. See how it works in live. So don't worry about the code and other things. This is a sample agent. I think this is for company research. Okay, so this specific one is actually built on LangGraph, and it looks like this. So simple. So first one will generate. This is an LLM. What it actually do is based on the input it gives. Okay, so the whole idea is that you need to research a company. So you can ask certain questions about a company. It will give you the response for all those questions. Okay, so that's kind of the idea. Now, first step, when you give the company name, so input is a company name. You can see the input over here. So input is company name. What information you want to extract is optional, and any other user nodes is optional. So you're not going to do all of those. So once you give a company name, it generates a list of queries I need to research on. Then another is sorry, this is a tool which actually do the research, search and get extraction, and there is another LLM which will like summarize information, and finally there is another LLM which will make sure that the information that we have gathered is proper. It is not any mistake or whatever. Okay, so validate the output that is generated by the previous LLMs and finally act. So this is a very simple company research. Again, you can give a single LLM, but the output may not be valid. The output may not be structured in the format you want. So you want to break it down to multiple LLMs. This is how we have to use. Okay, so let me do something like any company name. Come on, somebody.
I say Google.
Google is very generic.
Agent.club.
Agent.
Sorry, your company one. Just put your company. Applied AI.club. Let's see what comes.
So I'm not going to give anything. Let's see. So first it went to generate query. If you see founder history, investment news. So these are the queries it generated. Okay. So once it generates the query, it gets to the research notes. This is very interesting. Okay, it went to research notes, two different companies. Okay, it's still executing. Hey, look at this. Community, founding year, right? It's just, I think it just went to our website and tried to get all of the information. Now then it went to the gather notes schema. Okay, so it took, it summarized all this information. Founding year, this is wrong. And reflection says, is it satisfactory, true or not? And finally, this information, like what is gathered information, will be sent to the user. Okay, so again, just going through this, generate queries will generate based on the company name, what queries should I actually use to create. Second is the actual research, which uses a search tool to get the information. Information is all summarized, and finally take the summarized information and answer specific questions. What's the name of the company, what the summary, product description, founder names, founding year, etc. And finally, it's just a validation node which checks whether the information provided is proper or not. Okay, so this whole thing comprises of an agent. It has tools, it has multiple LLMs, and it helps you execute all of those things. Sriram.
Hey, I know you told me just refer to the video back, but this Langsmith, this is the UI which you showed. This is how you made the agent, or it's the UI outcome of the code?
It's just an outcome. It's an easy way for you to debug. It's provided by LangGraph. Even the Google's one also provides something similar, but it is their own proprietaries. It is not a common framework. There is one more company which has built a UI on top of LangGraph. It's called Langflow or something like this. Okay, I saw the UI. The UI it looks like anything.
Langfuse.
Langfuse, huh? Yeah, I don't understand how it works, so I have never tried it. But
So essentially, you write the code first in LangGraph, and then you come to LangChain to visualize. Is that
exactly? So the code looks like this. So we did it last time. So you have these different nodes. Each of these different nodes and how they are connected is given here, etc.
good? So you wrote that in LangGraph.
Over it again, yeah.
Good. So you wrote that in LangGraph and came to Langsmith for visualization.
Yes.
Thanks.
That's all we had, guys. I know we a little over time, but I'm happy to answer any questions.
Yeah, Bala, so is there any agentic tool for image models or any other model, let's say large font models apart
You
from
can use LLM. See, LLM is part of it, right? So if you remember, it's tools, multiple LLMs coming together to take action. Tools is how you take actions, and multiple LLMs comes for decision making. That is basically your agent. You put a multimodal agent within. You provide a image input or a video input. Doesn't matter. It works.
Okay, so like I can control the output of the image through simply like agents that it should not like the color bound should be like just these two hexadecimal, so it will control, right?
Yeah, exactly.
Okay. Yeah, thanks, Bala. Thanks for the session, and really enjoyed it. Like, hope to be part of it like again. So,
super, guys. Thanks. All right. Any other question, guys? Otherwise, we'll wind up. Super. All right. Have a good weekend, folks. Thanks for joining. Hope this was helpful. Again, this video will go up on YouTube. Feel free to pause and watch it again. If you have any questions, just ask us. Take care. Bye bye.